Number 3, they want you to find the long-run value for each sequence. And which one in particular might you want to do? Anybody? A, B, C, D, sir? C. Okay, let's take a look at C. In C, we have you starting with 62, and then UN equals 1 minus 0.2. Let me rewrite that. UN equals, what is 1 minus 0.2? 0.8. UN minus 1. Okay? So let's see what happens if we try to find the long-run value. There are 3 ways that you can find the long-run value in these problems. Okay? The first way is to use the calculator and do the recursion. All right? So on your calculator, you can say, okay, what is the first term in this sequence? 62, right? So the first term is 62, and hit enter. Then it says that the next term is 0.8 times the previous term. So you just say 0.8, actually, sorry, you can hit times 0.8, enter. So we have 49.6, we have 39.68, and then you just continue to hit enter until you kind of get tired of hitting enter, or until you think that it's leveling off or stabilizing or reaching a limit. That's really what they mean by long-run value, is they mean find the limit. That's the definition of the limit, is the long-run value. So you could see that we're getting very, very, very small decimals. So it looks like it's approaching 0. So that's the long-run value, 0. That's method 1. Limit of C is 0. If I was going to do C a different way, try method 2. Method 2 is to take this equation, the rule part of the equation. You don't need to know where it starts. You just need to know what the rule is. Take the UN equals 0.8 times UN minus 1 and replace the U's with X's. When is X equal to 0.8X? And then solve for X. We would take away 0.8X from both sides. You would get 0.2x equals 0. And sometimes students will panic when they get 0 in a problem, like 0 is not a real number or something. It is. It's allowed to be the answer, because it is the answer. When you divide both sides by 0.2, this is legal. If that was flipped upside down, there'd be no solution, right? It would be undefined. But 0 divided by 2 is 0. That's the long-run value. The third method can be done. Let's think about it. Let's do A. Let's switch problems here. Let's do part A with the third method. You start with 48, and then it says the next term is 75% of that plus 25. Well, if you take 75% of 48, what percent is going away? 25%, right? So this problem, A, 3A, is losing 25% every time. But what is it gaining back? Just plain old 25. Not 25%, but 25, right? So it loses 25%, and then it gains 25 back. The limit comes from figuring out 25% of what equals the 25 units that we're getting back each time. That's one of the methods we talked about yesterday. You would actually get this line in your equation if you would have done method 2 that I talked about just now, where you replace these with x's and solve. The second line here would be, if you take away 0.75x from both sides, it would say 0.25x equals 25. Solve this by dividing, and x must be 100 in that problem. Okay? In all of those methods, well, in 2 of those 3 methods that we did, we actually ignored what the start value was. It really doesn't matter. No matter what you start with, this will eventually reach a limit of 100. This will always reach a limit of 0, no matter what you start with. The only one where we used the start value was on our calculator, where we had to start somewhere. We had to get the ball rolling somewhere. So that's how you do number 3.